All right, Math 2, it's time to get started with some algebra review. So we are not going to be reviewing all of algebra, of course, but just basically the things that we need for this Math 2 class. And we're starting with the rules of exponents. So with exponents, we have things like if you have a product and it's raised to the n power, then basically you can distribute that n power to both the a and the b. Another one that looks similar is what if you have, instead of a and b, you have a times a, and one of them is raised to an n power and the other one is raised to an m power. In that case, you add the exponents. Next up, what if you're dividing? So if you have a to the n, and this time it's divided by a to the m, well, then you subtract. And it does need to be the top one minus the bottom one. So it's going to be a raised to the n minus m. Another important one is when you have a negative exponent, then what that means is you invert whatever was being raised to that exponent. So a to the negative 1 becomes 1 over a. Another useful one is if you have a to the 1/2, that's the same thing as square root. So with this lecture, I'm going to try to keep the theory down to a minimum and show as many examples as possible. There's just one more in this theory part, and that is if you have a raised to a 0, then that equals 1. So just as a quick demonstration, and also to show you I will be using the calculator quite a bit. We don't need that graph. I just wanted to show you if you take something like 8 and then raise it to the 0 power, then that equals 1. So I always have my calculators set to 3 decimals. I like to just set it and forget it. So just put if you go to mode, then put the float on 3 decimals, and then second quit, and now everything's going to be 3 decimals after that. Okay, then for some examples with these exponents. So for example number 1, suppose that we have 3x to the 4, y to the 7, all of that is squared, and 5x to the negative 2, y to the 2 is being cubed. And by the way, when I made up these examples, I actually went through the online homework and looked at what they're asking for, and so these are similar to the online homework. So first of all, this square needs to apply to all 3 of these things. So there's going to be 3 squared, and oh, here's one I forgot to mention. It's okay, now I can mention it right now. When you have a power and you raise it to another power, you actually multiply these two. So for the x, it's going to become x to the 8. And when you have y to the 7 and it's raised to the second, multiply these two, so that's going to be y to the 14. And then cube, so there's going to be 5 cubed, and I'll simplify that in the next step. And again, multiply these two, so that's going to be x raised to the negative 6. And then finally, this is going to be y raised to the 6th power. So now let's see, there's a 3 squared and there's a 5 cubed. Of course, I could say that is 9 times 125 and multiply that in my head, but I don't know what that is, so I'm going to use the calculator. So the squared button is over here. It says x squared, but it just means squared. So we've got a 3 squared times a 5. And now if you need an exponent bigger than squared, you should use this up arrow right here. So raise it to the 3rd. So that's basically saying what is 9 times 125? And it equals 1125. So we have 1125. And then if you look at the x's, there's 8 of them right here, and then minus 6 of them right there. So the general rule is when the bases are the same, x and x, you add these numbers. So 8 plus a negative 6 really means 8 minus 6. So that's x squared. And for the y's, there's 14 of them, and then there's 6 more, so that means a grand total of 20. So y to the 20. And then that's my final answer. Then for example number 2, how about if it has a fraction? So what if it's one big old fraction, and then we've got 6x to the negative 3, y's to the 5th, all of that is being squared. And on the bottom, there's just a 12, x to the 4, and y to the negative 7. So what I would do is simplify on the top first because everything needs to be squared. So there's going to be a 6 squared, and I know 6 times 6 is 36, so I'm just going to go ahead and put that. And in here, multiply the exponents. So 2 times negative 3 means we've got x to the negative 6. And then y is going to be 5 times 2, so that's y to the 10. And for now, I'm just going to recopy the bottom and then simplify for my last step. So with these negative exponents, I basically am going to be using this. So if you have an a to the negative 1, and this is basically in the top of the fraction, that's going to move it to the bottom. And likewise, if it had the a is in the bottom of the fraction, but it has a negative exponent, then it moves it to the top of the fraction. So basically the negative exponent says switch places. So that means that this x to the 6th could be moved to the bottom, and this y to the 7 could be moved to the top. Also, I know that 12 will divide into 36 3 times, so that's going to be part of the answer. So the 3 is on top, and then I'm going to move this x to the 6th to the bottom, so that means I've got x to the 4, and then his friend joins him with x to the 6th, so putting the x's together. Also, the goal is to not have negative exponents, so I'm moving this to the bottom so that the exponents are not negative. And then this one needs to be moved to the top. So the y to the 10 was already living there, and then the y to the 7 joined them. And then finally, this one is going to be a 3 on top. And as far as the y's, when you add these two together, that's going to be y to the 17. And when you add these two together, that's going to be x to the 10. The next example is going to involve square root. So for example number 3, if you have the square root of a 24, x to the 6th, and y to the 7. So because square root can be rewritten as the 1/2 power, that means if you have something like x to the, let's just make something up, x to the 8, then you can rewrite that as x to the 8 in parentheses and then raise it to the 1/2 power. Oops, looked like I was getting a little bit off the screen. Here we go. And then because you multiplied these two, then you multiply 8 times 1/2, so that means that the 8 gets cut in half, and so it's going to be x to the 4. That's going to work out very nicely for this one because this, I will just cut this exponent in half. Now this one cannot be cut in half evenly, so what I'll need to do is factor that one. And so I'm going to leave the x to the 6 as it is, and then with the y, I'm going to factor off one of the y's. So it's basically like this. So put 6 of them right here, and then the extra one, so you still have y to the 7. And then with 24, so that I want to factor it, and I want to factor it into something I know the square root of. So 24 can be factored as 4 times 6. Then I just put my square root back, and then we're ready to simplify. So when you take the square root of 4, that's going to be a 2 on the outside. The 6, I cannot take the square root of, so that's going to have to stay on the inside. When you take the square root of an x to the 6, well, it cuts the exponent in half, so that's going to leave x to the 3. And the same thing happens with this y. Cut this exponent in half, so it's going to be y to the 3. And lastly, this single y remains on the inside with the 6. And then this one is done. Okay, on to the next idea in this section, which next is about lines. So if you have 2 points, which I'm going to call x1 comma y1 and x2 comma y2. So that's basically saying if you went to x1 right here and y1 right here and made a dot, and then you go to the second point called x2 right here and y2 right here and made a dot, then there's only going to be one line that goes through there, and we're going to find the equation of that line. So that requires 2 steps. One is find the slope, and the slope measures the steepness of the line. So it's basically going to tell us what angle this line goes at. And the formula for that, so for some reason m is used for slope, basically because it's measuring the steepness. So m for measuring the steepness, I guess. Anyway, it goes subtract the 2 y values, y2 minus y1, and then on the bottom you subtract the 2 x values, x2 minus x1. That's the first main step. The second step is use the point slope formula. And that goes take the letter y minus whatever number you had for y1, and then put the slope, in other words, the answer that we got from this, times parentheses the letter x minus whatever x1 was. And then at the end, we'll solve for y, and then that will be the equation of the line. So for example, find the equation of the line. I was just trying to see which number example this is, number 4. So for example number 4, find the equation of the line through 2 points. And I'm going to use 2 comma 7 and 4 comma 13. Okay, so the first thing to do is find the slope. So this is x1, y1, x2, y2, and you could label them that way, but you don't actually have to, because if you do this, so the slope formula says subtract the 2 y values, and you just make an arrow showing which direction you subtract. So I'm going to go 13 minus 7. And that literally is the y2 minus y1. And then you subtract, and you just have to go in the same direction. So it's going to be the 4 minus the 2. So let's see, on the top, 13 minus 7 is 6. On the bottom, 4 minus 2 is a 2, which means that the slope is 3. Now do the point slope formula. So that goes y minus the y value. You can use this point or you could use this point. They're both going to give you the same answer, because if you use this point to find the line, you're going to find this line. If you use this point to find the line, you're going to find the same line. So whichever looks easier, I think these numbers are smaller, so I'm going to use this. So the formula goes y minus the y value of 7 and then put the slope in front of the parentheses, and then go x minus, the number for x was a 2. And then the last thing we need to do is solve for x. So I'm going to distribute this 3 on the right side. There's going to be 3 times x minus 6. And then there's only one more step to solve for y, and that is add 7 to both sides. So finally we're left with y equals, so the 3x stays there, and then a positive 7 minus a 6 is going to be positive 1. So at that point I am finished, but I also at this point want to show you how to use the calculator. So let's graph this and then make sure that it goes through those 2 points. So get your graphing calculator, and first I need to turn it on. And then you go to y equals. If there's some extra junk in there like I have, then just use the clear button right here to clear it out. And sometimes if your calculator says error, it might be that somebody left on one of these plots and it's confusing the calculator. So if that happens, just go up there, hit the enter, and now that's off and the calculator won't be confused. So now we're going to graph this, y equals 3x plus 1. So the x is right here, even though it says x and t and stuff, it really is x. Look, x, 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 x. Okay, so I need 3x plus 1. And then the best way to get to the graph is go right here to zoom. And number 6 is the best place to start, zoom standard. And then you'll see that it draws the line, and I just want to make sure that it goes through these points, 2, 7. So to do that, you just go to trace, and you plug in a 2, and then right there, it says the y value equals 7. So that is correct. Next, I want to see if this 413 is right. Since I already pressed trace, I don't have to press it again. I can just say 4, and it will say x equals 4. And on the bottom right, when you hit enter, it says y equals 13. So that is correct. Okay, then on to the next idea that they talk about on the homework, and that is if you have 2 lines. So if you have 2 lines and they don't intersect, that's called parallel. And that means that whatever the slope for this one is and whatever the slope for this one is, they have to be the same because they're going at the same angle. So the slopes are going to be the same. So slope number 1 has to equal slope number 2. Then the next idea is, what if they are, instead of parallel, they're perpendicular? So this, when they cross, is 90 degrees. And let's say this is slope number 1 and this is slope number 2. So this is for perpendicular. In that case, whatever slope number 1 is, it's going to be the negative reciprocal of slope number 2. And now we'll do an example. So this would be example number 5. And example number 5 is, suppose you're given a line already. So given 12x minus 2y equals 3. So maybe that's this line right here. So given a line already and a point, so basically if this is the original line that I just wrote down right here, and then you're given a point, then find the equation of the second line. So that's part A. Find the equation of the line parallel to the given line. Well, for parallel, that means their slopes need to be the same. So that means for this one, I need to find its slope. And if I solve for y, then the number sitting in front of x is going to be the slope. Just like with this example that we did, we found out the slope is 3. So when you solve for y, this number sitting in front of the x, that's the slope. So we need to solve for y in this equation. So one thing I could do is subtract 12x from both sides. So then I would have negative 2y on the left side, and then I would have negative 12x plus a 3 on the right side. And then the last thing to do to solve for y is just get rid of this negative 2 by dividing everything by a negative 2. So these are going to cancel, leaving y equals a negative divided by negative is positive, and 12 divided by 2 is going to be a 6. So this is going to be 6x, and then minus a 3/2, which doesn't really matter because I just needed to know what's the slope. So the slope is equal to 6. And we already have the point that it's going to go through and the slope. So that means we can use the point slope formula to find the equation of the line. So I can then go y minus the y value, and that is a negative 1. So y minus a negative 1 equals the slope, and then x minus the x value, which is 2. And right here, a negative negative will make a positive, so that's y plus 1. And then I just need to distribute the 6. So on the right side, it's going to have a 6x minus a 12. And then there's only one more step, and that is subtract 1 from both sides. And that's going to be y equals 6x, and then this is going to make a negative 13. So that would be the line that's parallel. Okay, so I was going to do a part B, but I was just looking at my notes, and we're at 22 minutes, and I still have a few things that I need to do, so I'm not going to do a part B there. I'm going to go on to the next idea. Okay, so that was lines, and now what's called quadratic functions. And that is just a big word to say it's going to have an x squared in it. So in general, you'll have something times x squared plus some number times x plus some other number. So this is a general quadratic function. And let me just show you real quick how to graph that. So if you have y equals, so let's just say negative 2x squared plus 9x plus 4. Then what does that graph look like? So this right here is a negative. So if I have something like 5 minus 8 equals negative 3. And suddenly you're thinking, why are you talking about that? It's because the calculator says these two things are different, which they are, but when we write them, we always write them as the same little straight line. But this one means subtract, and this one means negative. So on the calculator, this one is for negative, this smaller one right here, and this one is for subtract. So actually on the calculator, it would put basically a shorter line, and also it puts it a little bit higher when it means negative, and then it puts it in the middle when it means subtract. Now I'm making a point of that because when we go to graph this, quite often when people start, they'll accidentally put the subtract sign right there, and the calculator will not graph it. That's why I'm going over this. So let me just show you on the home screen what I was talking about right here. So 5 minus 8, and then what does that equal? So this is in the middle, and it's a little bit longer to mean subtract, and then this is the negative symbol. Okay, now we can graph this one. So go to y equals, and then this one is the negative, so make sure you use this negative 2x, and then the squared is over here. And then I put plus 9x plus 4. And again, the best way to graph it is go to graph standard. So this basically makes what's called a parabola. So it looks like this. And the very top of it, I can't quite see. So these y values right now, they go up to 10. So I need to make it go up a little bit more. So I'll just go to the window and have the y value, the y max, instead of going to 10, how about if I go to 15? And then when you do that, just go back to graph right here. And then we could see the whole thing. So that's called a parabola. And we will work with parabolas quite a bit. Okay, back to, so that was just the calculator part. We still need to do the math part. So example number 7, I believe it is. Okay, if it's not, then let's just pretend it's example number 7. So the first one is solve this equation by factoring. And part A is going to be 2x squared plus 7x minus 4 equals 0. And then factor that. Or in other words, what were the two things that were multiplied that when somebody multiplied it out, they got this? So you always start with this. So what are two things that would multiply to give you 2x squared? Well, for 2, that would just be 2 times 1. And for x squared, it would have to be x times x. The next thing is, what are two numbers that give you a 4? So there's 1 times 4, and there's 2 times 2. So it's basically a guess and check. So I'm just going to guess first. What if it's 1 times 4? If this doesn't work out, then I'll go back and try 2 times 2. But right now I'm just going to try the 1 times 4. Also, it has to be a negative. So that means that you have to put a negative and a positive. Or perhaps this is supposed to be the positive and this is supposed to be the negative. Well, here's how we find out. So when I multiply 2x times x, that's x squared, that part's right. When I multiply negative 1 times 4, that's negative 4, that part's right. This is the part that I have to check and make sure I did that. So when you multiply these two terms, that's going to be negative x. And when you multiply this one and this one, that's going to be positive 8x. And when you combine a positive 8x minus an x, that's a positive 7x, which is exactly what it was supposed to be. So that means that I factored it correctly. The next thing you do is you basically separate it into two problems. You say put the first one equal to 0. Put the second one equal to 0. And then solve each one of these separately. So with this one, I could add 1 to both sides. That's going to leave 2x on the left side equals 1. And then divide by 2 and divide by 2. So x is equal to a half. With this one, all I need to do is subtract 4 from both sides. So that means x equals a negative 4. And what we're going to be doing a lot in this class is solving problems using math and then use the calculator to check and see if we got it right. So I'll graph this problem. So let me just erase that and put the new one. So 2x squared plus 7x minus 4. And then zoom standard. So whenever I type a new function, I always start with zoom standard. Okay, now I need to check, is this x equals 4 correct? Well, this was saying when does the function equal 0, and there's two places, right here when it crosses the x-axis, and right here when it crosses the x-axis. I'm thinking this one is -4, so let me try. So you just go to trace and put -4, and hit enter, and it should say y equals 0, and it should show you that is where it's crossing the x-axis. So that one is correct. And our other answer was the 1/2. So if you type in the 1/2 and hit enter, sure enough, it says it equals 0, and then that's where it's crossing the x-axis. So these two are perfect. Yes, 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 we will do more. I'm glad that you asked. Here we go. Ready? Number 8. So again, okay, I was going to call this one 7b. I guess it doesn't matter. So again, factor and then solve. This one is going to be x squared minus 81. So you can factor in the same way as I did last time. So what are two things that multiply? And always start with the first one. So in order to get x squared, that comes from an x times an x. And then what are two numbers that multiply to give you 81? The first one that comes to mind for me is 9 times 9 equals 81. Also, it needs to be a negative, so one of these needs to be positive and one of them needs to be negative. So this is a special example. This is called the difference of squares, and so it always turns out very nicely. It's just x plus a number, x minus a number, and whatever these two numbers multiply to give you that, you're done. And then set this one equal to 0. Set this one equal to 0. And in here, we just need to subtract 9 from both sides, so x equals -9. In here, just add 9 to both sides. And then it's going to be x equals +9. So two answers, +9 and -9. Now there's also something called the square root property, and we could actually do that to solve this one. So let's say we start with the same thing, x squared minus 81 equals 0. And with this method, what you do is you move the 81 to the other side, so you add 81 to both sides. And that way on the left side, the x squared is just by itself. And then the square root property says, take the square root of both sides. Notice that this one comes up with two answers. Whatever the highest exponent is, that tells you how many answers you're looking for. Since this is squared, we're looking for two answers. This one was squared, we got two answers. If it happens to be x to the third, then we would have three answers. So since this one has x squared, there's two answers. And the way you get both of those answers is, for the square root property, you take the square root of both sides, but whichever side has the number, you say positive or negative. Because notice there's one negative and one positive. So when you use this little shortcut right here, it works nicely. Just remember to put plus minus. So the square and the square root cancel each other out. So x equals plus or minus, and then the square root of 81 is 9. So we got the same answers, +9 and -9, but this way is a little bit faster, but there are some times when you do need to factor, so both of those are valid. Okay, so now on to complete the square. So basically with these videos, I'm going through the stuff you need to be able to do for the homework. So as we go from one idea to the next, perhaps you want to just pause the video and take a break. Perhaps you've already done that 2 or 3 times. So we've got 2 more ideas to go. Complete the square and then the quadratic formula. So next, complete the square. So complete the square basically says, so you've got some problem and you're trying to factor it. And with me, on this one, I happened to guess the numbers correctly the first time, and it worked out. I was able to factor it. But then the idea is, well, what if you try the 1 and the 4? That doesn't work. And also 4 is 2 times 2, so you try 2 and a 2, and that doesn't work. Then what do? You're just stuck? No. Then you can complete the square. So I'm basically going to go through the way that they did for the online homework and basically build it up. So this would be example number 9. So basically, if you have a polynomial x squared plus 6x plus, and we don't know what this number is, and then you're trying to factor it into x plus something, x plus something. So complete the square means this problem is incomplete because this number's missing. And when you factor it, this should actually be the same number each time. And with this one, there's even a hint. What if it's supposed to be a 3? Or in other words, what if you're supposed to factor it? X plus 3 times x plus 3 is the same thing as x plus 3 squared. So that's why it's called complete the square. So complete is saying what goes here, so that when you factor it, it's a square. Well, if you look at this and the 3 is going to be squared, that would be a 9. So what's missing right here is a 9. And then if you multiply, this would be x squared. That's correct. This would be 3 times 3. That's correct. That's 9. This would be 3x, and this would be 3x, which makes a total of 6x. So it works. For example number 10, what if I just leave off one more piece of information? So this is missing, and then x plus this is also missing. So what number goes here and what number goes here? Well, if you go back to this, we already had the hint because over here was a 3 times 3. So I just multiplied those and said it's 9, and it turns out that was what I should do. But with this one, the number's missing. Well, if you go back to this one up here, if you take this number, whatever's sitting in front of x, so you take that number and you divide it by 2 and you square it. Well, 6 divided by 2 is 3. And if you square 3, it's a 9. That is really where that friend came from. So let's do it for this one. You take the number in front of x, divide it by 2, and then square it. So 8 divided by 2 is going to be 4. And then you square it, that's 16. So that is what goes right here. And then to know what number goes right here, well, that was just the step right before it. So a 4 squared is 16. So this must be a 4. So that when you square it, it's going to give us that 16. Okay, now let's do one more. What if it was 2x squared plus 16x minus 4? Okay, so this one, I'm taking away the hints over here. And this one has something slightly different. It's got 2x squared. And notice this started with x squared and this started with x squared. So in order to complete the square, this does have to be an x squared. So the first thing I'm going to have to do is factor out a 2. So that's going to leave x squared once you factor this 2 out. When you divide this by 2, it's going to be 8x. And then notice how I left a blank right here on these earlier ones? Well, that's what I need to do right here. So you just have to do it yourself and go plus and then leave a blank. So I factored the 2 out of this, and then I also need to factor the 2 out of this -4. So that's going to be divide by 2 is -2. Okay, now this one is set up like that one. So it's going to be take the number 8, divide by 2, and then square that. And of course, that's going to be 4 squared equals a 16. So this part is going to be later. Right now we're just working on this part. So that means right here, there goes a 16. So the 16 goes in here. Now on this one I had an equation, so I put a 16 right here, and also in red basically I put 4 squared, so I put a 16 on both sides. And whenever you're working with equations, you do need to put the same number, add the same number to both sides. With this one, I don't have a right side. So what I have to do is compensate for that and basically say, I do need a 16 here, and then I'm going to subtract it right back out. So that does seem sort of weird at first, but then again, if you think about it and you say, I need a positive $16 that I don't have, so I'm going to have to borrow it from somebody. So my cousin gives me a positive $16. That means I owe my cousin $16. So later I'm going to have to pay out $16. Okay, enough with the debts. Next, we just need to factor. So this 2 is just going to stay on the outside for the rest of the problem. And then it's these 3 that can be factored. And so that basically turns into this. So that's going to turn into x plus 4 is squared. So that takes care of all of this stuff. And then when you put these 2 together, there's a -16 and a -2. So that's -18. And then this 2 is supposed to be times everything. So I actually need to put double parentheses saying the 2 is times everything. And then that is complete the square. And minute 42 of the video, we're finally to the last idea, and that is, what if it cannot be factored at all? Then we have a formula that will work each and every time. And you might think, well, why didn't we just do that from the beginning? Well, there are times when you need to complete the square, and there are times when you do need to factor. So it's not like these are a waste. We definitely do use them, but then sometimes we need to use quadratic formula. And again, with these weekly notes, I'm basically just trying to go over exactly what you need for this week's work. Nothing more, nothing less. So the quadratic formula. So it basically goes like this. If you have a quadratic, so as I mentioned a while ago, if you have ax squared plus bx plus c, and then you're trying to solve that problem, you're trying to solve for x. And how many solutions? You're right, 2. So the quadratic formula goes like this. If you want to know what x equals, the formula goes take negative of the b, and then it goes plus minus because there's 2 answers. Then it's the square root. Inside the square root is b squared minus 4 times the a times the c. And the whole thing is divided by 2 times the a. So that's a formula we're definitely going to be using a lot throughout the semester. Okay, then for the last example, which I believe is number 12. So if we have 2x squared plus 16x minus 4, and it equals 0. So you could, notice that problem looks very similar. You could complete the square, and then once you're done completing the square, you could set it equal to 0, and then you could start doing the algebra to solve for x. or you could use the quadratic formula and it goes faster. So this is the A, this is the B, and the -4 is the C. So then the quadratic formula is going to go take negative of B, so -16, plus or minus the square root, and then 16 squared minus 4 times the A, which is 2, and the C, which is -4. And then make sure the square root goes all the way. Also important with the quadratic formula is this is one big fraction. So a very common mistake is people will do the quadratic formula and they're writing their numbers up here and then it's divided by 2a. And then they start simplifying and then their divided looks like this. And then they've got these numbers and then their divided looks like this. And then you can't really tell. And then when they type it in the calculator, they don't type it as the whole thing is divided by 2a. So just make sure that you make one big fraction bar and the whole thing is divided by 2a. While we're here, another quick pop-up ad is if you have divided, so 2 divided by 3, you should write the fraction like this. It is 100% legal to write fractions like this, but it's not a good idea because if we have something like 2 divided by 3 plus x, the numerator is 2, the denominator is 3 plus x. But what if I wrote it this way and I go 3 plus x? When you write it this way, does that mean 2 is divided by 3 and then after a while later the x is added, or is the x supposed to be in the bottom? So this es mejor. So that's my fraction speech. Now make a big old fraction and say divided by 2a. For this part, I would like to just do this on the calculator. So not even with the square root, I just want to simplify what's inside the square root. So I don't need the graph, I just need the home screen. And so I just need to know what's 16 squared and then minus 4 times 2 times, and then this one is the minus on the left side of the calculator, and this one is the negative, the one at the bottom of the calculator. So it's 288 that's inside the square root. So you've got x equals -16 plus or minus the square root of 288 and then divided by 4. And then we're going to get 2 answers. So this, I would type the whole thing in the calculator. So don't do it in pieces, type the whole thing in the calculator. And when you do, the calculator needs to know this is the numerator, so put parentheses around it. You don't have to put parentheses on the bottom when it's only one number, but when it's more than one number, you should use parentheses. So use the parenthesis above the 8, and then -16 plus the square root of 288, and then I need this red parenthesis. Oh, by the way, when you're in the square root, it's going to have a little arrow saying if you want out of the square root, use the right arrow. And then parenthesis divided by 4. So one answer is 0.243. Oh, too bad they didn't put them in order 2, 3, 4. That would have been cool. Okay, anyway. Then I need to do the same thing with subtract. So put parentheses, -16, subtract the square root of 288. Get out of the square root, put the paren, and then divide by 4. And then it says -8.243. All right, so that's it for week 1.